Foundation of power electronics conditioning and filtering, power flow and exchange in EV. Hello everyone, in this lecture we're going to learn about how the power flows from the batteries and it reaches up to the wheel assembly. So we'll get to know about how things flow or how the biasing takes place for say an hybrid. So whenever the engine wants to give the power, so engine is going to act, and whenever battery wants to power, so for say for the first 10 to 20 kilometer per hour speed, so it will be acting. So we'll get to learn more about this in the whole session. So before that, we'll try to understand what all topics we are going to cover. Okay, so we're going to learn about first the front wheel drive and get to know about its benefits and drawback. We actually see that most of the vehicles on the roads are the front wheel drive cars, right? So next to that we have the rear wheel drive. Similarly, we are going to cover the benefits and the drawbacks of the rear wheel drive and why it's important to have a front wheel drive also will be covered. And at last we are going to learn about the hub mounted motor systems, where the motors are actually placed in the rim itself. So these are in the same axle, and directly instead of having say a rear placed or a front placed motor, we can actually place the motors in the wheel assembly itself. So let us try to understand what all objectives we are going to cover or what things would be covered by the end of the session. So we'll get to learn about the front wheel drive and the rear wheel drive. Okay, so the best benefits of those cars which are done in that. Also we'll learn the suitable architecture for the amongst front wheel drive, rear wheel drive, and it could be the hub mounted motor systems. We'll also try to understand how there is a flow of power from the battery to motor and motor to the driveline systems, and we'll try to uh, check several configurations of say front wheel drive hybrid system or rear wheel drive hybrid systems or fully electrics at the hub mounted. Okay, so now moving ahead with the first point, which is the front wheel drive. So we have the front wheel drive, which actually means the motors are placed ahead. Okay, so in case this is a electric car by Hyundai Kona, so we have the motor placed right beneath the hood, so it's almost in this section, right? And they are already pulling the car from the front wheel assembly. So these are actually pulling the whole car through the front axles. So these are just suspended, or we can say do not contain any power, and the whole battery systems is beneath the driver compartment. And this is how the biggest feature is the front wheel drive. So if we check, these kinds of cars are quite safe and economic, because what we actually see is that most of the components are placed here, and it's quite, we do not need to make additional component systems and increase the weight accordingly. So all things are packed in the front, and even in a case of say frontal crash or say some 45-degree crashes, the whole, can say most of the energy could be absorbed by the motor, or say if it's powered by an engine, it will get crumbled, so less of damage to the driver or the occupants. Okay, so there are something we can call as it has, as it's pulling, so it has a less chance of getting it spinning, right? So you cannot it's bit harder to drift as well. So even people know that how it's easy if you are having a rear wheel drive, and people tend to drift it. Okay, so now let us try to understand the advantages of the front wheel drive and why we see these kind of configurations in the on roads. First is that it's completely expensive as all the components are placed at the front. So uh, there is an absence of, say, shaft, then the differential at the rear, and there could be complications at the rear. So that's why all things are placed at the front. So most of the things will be absent in this part. Okay, so this is the major thing what we see in the front wheel drive. Next is it's quite easier to drive, or say it's quite easy to learn quicker and drive it, because the rear wheel drive at times become problematic due to spinning, and because the power is transferred to the rear wheels and the front wheels are just meant to be just steered. So it's quite often, we can say, easy when all things are at the same place. Also it has a better transmission as everything is rightly placed in the front section, so there is a less chance of losing the power or losses what we actually see in the transmission, in which is placed here, then going through the drive shaft, then going to differential, and by going through the joints it reaches the wheel. So there is a lot of, we can say, losses behind that. So that's how all things which are, if they are being put here, so there will be a better transmission systems. Next is increased fuel economy. So when we talk about the all points, when we discuss, it tends to give us increased fuel economy because the less of components, the losses are less, so at the end it's going to consume less fuel, so hence it has increased fuel economy. Okay, so now, as everything has some advantages, it also has disadvantages or the drawbacks. So it has some of the higher maintenance costs, because there are things such as the differential placed, then we have complex steering mechanisms which are due to packing of the whole front hood, right? So it becomes quite difficult, so there is a lot of maintenance involved in it. So this is one of the drawback, which is one of the major. Difficult to handle torque steer, as we have the power at the front wheels, so such kind of parameters tend to hamper the steering, right? Because they are being steered as well, and it also has to be pulling, so there are plenty of, say, complexity found in the front wheels. So next point actually also helps it to support is, which is the poor handling of car. So if you try to drive it on, say, road, there could be times there could be slipping or, say, instability because of the whole mechanisms of steering and the torque which is being achieved from the engine or, say, the motors. Okay, so last, which is the complex front mechanism, is all about, there are around, say, 8,000 components which are placed in the front of the hood. So these involve all the fasteners, the motor, say, wiring, winding, then we have plenty of motor leaves, right? So there are, as more number of components are there going to be there, more the complexity is going to happen for that. Okay, so now moving ahead with the next is the rear wheel drive. So when we talk about the rear wheel drive, how we can actually define is by the car segment which has being powered by the rear wheels. So the motors are completely acting at the rear. Okay, so this is the major way, or this is the rather the correct way how we can define the rear wheel drive. So what are the advantages of the rear wheel drive as what we compare to the front wheel? So we can say that there are quite a less of, we can say, advantages, but most of them is that the better handling than the front wheel drive, because all the front wheels are just for steering and this rear wheels are just for the pure rolling. So this is how it achieves a better handling than the front wheel drive. In this configuration, the actually car is pushing, so the motors or the engines are actually pushing the vehicle than what we see as pulling at the front wheels. Okay, so it can handle more horsepower than front wheel drive. And how we can actually handle horsepower is that there is less of, say, we can say slippage or a better maneuverability on top speeds or say during traffics, and it becomes quite easy to handle than the front wheel drive. So next is the simple transmission than the front wheel drive, is because all the forces or all the power is just, if it's placed at the front, it goes to the rear and then it's power by the drive shaft, then the differential and the wheel. But if it is placed at the front, there is plenty of squeezing of components to put the power to the front wheels. So as there is a differential placed at the beneath, we have them some solid shafts, some wheel assemblies, so it's going to almost distribute the weight. So there could be some 5 to 10% of weight distribution change plus or minus depending upon the configuration. So few of the drawbacks are that there is a higher cost of transmission, because we have some of the kit which is being running from the front to rear, and it's going to be evaluated to pay. So you need to pay more for the components you are using so that your power reaches to the rear. Less cabin space, so as the drive shaft goes through the whole cabin, between the cabin, you actually need to have it, say, covered like a tunnel, so that's how it's going to eat some of the cabin space. One last drawback is the pushing the vehicle, which is actually tough to handle on the low surface grip surfaces such as the ice. So at times it becomes a bit harder to handle such kind of vehicles on the ices. Last but not the least is the hub mounted, we can say, tires or the assembly cars. So the best thing about this is that the power is directly transferred to the wheels, and there is a better weight distribution, so you can lower the CG and the polar moment, so that's going to give a better traction control. So this is one of the major feature and what we can actually see. So also it's going to give us a better cabin space. You can place your cabin or you can have some of the space used for the batteries for a longer duration or the longer run of the vehicle. Okay, so now moving on to the next slide, which is the now let us try to understand how it's actually acting. So we have this SUV electric, and let us try to understand how the power flows from the batteries, from the engine, and that's how it reaches to the tires. So we have this battery which is powering the motor, right? So there is a battery. Let me hide this for you. Okay, so this battery will power the motor, or it will take the charge, and then it will, what we see is going to power the differential. So it's a rear wheel drive, it's actually powering the rear wheels. So we have some inertia, rotational inertia, which is imparted, then we have the power coming to the differential, and then differential it goes to the tire. So this is how it actually travels for a rear wheel electric drive. Okay, so also we can attach the motor and transferred it to the front wheels, but we are currently restricted to just the rear wheel drive configurations. So we can actually try to calculate and achieve the results accordingly. So in this setup we have some of the drive cycles where we can actually make the vehicle run on certain road conditions depending upon the vehicle speed, then the timings according to the path. So one can have a mountaineer kind of path, or say highway, or depending upon more stops, or say more of turns. So those kind of graphs are necessary. So then we have a driver control which gives the input according to the we can say drive cycle, and then there is a collaboration between say driver breakout and the electric vehicle circuits which are being controlling the whole car system. Okay, so this was all about the SUV electric. Now moving ahead with the mid-size hybrid. Okay, so we have just considering a hybrid vehicle. Okay, so what happens is that there is some biasing which is done between the engine and the battery, and this setup actually tells us that how the it actually interface or the clutch works. So if you want to give engine, you can give out the engine, and then by engine it will go to the whole gearbox section, and then it goes to the drive shaft. So this is all-wheel drive kind of configuration what you're looking for. So we have a motor which is traveling and then goes and then at last goes to the whole vehicle body. Okay, so we have the battery and motor, right? Then we have the engine which is powering the whole clutch system, and then clutch, then goes to gearbox, and then it goes to drive shaft, and at last it reaches the vehicle. Okay, so this was all about the mid-size hybrid we were talking about, and how the power reaches at the all wheels, and this is how the whole car works for the hybrid vehicle. So I hope you understood how we can work upon the configurations and make the vehicles run and enjoy the privileges by the front wheel drive or the rear wheel drive or the hub mounted or any kind of configuration if those are just pure combustion parts. Okay, so that was all for today's lecture. See you in the next session.